Okay, this is the video for Unit 2 review, page 5 and 6. So for this particular question, number 26, you're going to need your sheet that gives you all the steps for the calculator. If you don't have this, then you can get this from your teacher. They should have given it to you the day of this topic in class. Okay. So the first thing we're going to do is you have to have a calculator for this. So if you do not have a calculator, if you're trying to do this at home, I suggest that you come during Wolverine time or after school to do this part of the review because it does require a calculator. Okay, so it says the following table shows the winning jumps in the men's long jump event at the Olympic Games since 1968. Use 1960 as x equals 0. Okay, so basically what that's asking you, or what that is telling you, is that in 1960 x equals 0. So notice here that they've given different years. So you're starting at 1960, which means that 61 would be x equals 1, 62 would be x equals 2. So then that gives us, what you want to do is write the corresponding years from 1960 over here before you enter anything in the calculator. So this would be 8. Notice this jumps all the way to 1972. So 68, 69, 70, 71, 72. So that's going to be 12. Notice it jumps to 76. So basically I'm counting the years. If it's easier, you could write it out like this. 1960, 61, 62, 63, 64, 65, 66, 67, 68. Okay, so this is if you wanted to do it out the long way so you understand what's going on here. So notice that we needed 1972, so 72 is x equals 12. And then this would be 16, this would be 20, 24, 28, 32, 36, 40, 44, 48, and 52. So you're not going to use the years for this. You're actually going to, because 1960 is x equals 0, so you're going to count from there to come up with what x equals for each of those years. Okay, and then we have the names, and then we have the results of how far they jumped in the long jump. So the first question is, write the equation of the line of best fit. So what you need to do is you've got to take your calculator. First thing you're going to do is you're going to turn your diagnostic on. Okay, to turn the diagnostic on is this right here. So we're going to go to the catalog. So second and then 0. And you're going to type D. See right there where it has the green D? It's going to jump down to D. I'm going to scroll down to diagnostic. And I want the diagnostic on. I'm going to press enter. Enter one more time and it'll say done. So you need to have your diagnostic on for these particular problems. Remember, every time a calculator gets reset, the diagnostic gets turned off because that's the default. Okay, so the next thing is you need to create a scatter plot. So creating a scatter plot is right here. Okay, so I need to enter all the data into the calculator. Stat, I'm going to go edit. If there's information in here, you're going to clear, and you can clear by going clear down arrow, clears everything, clear down arrow, clears everything in that list. And we're going to enter the year, the L1. Okay, so in list 1, I'm going to put all the values of x. 8, enter, 12, enter, 16, enter, 20, enter, 24, enter, 28, 32, 36, 40, 44, 48, and 52. Okay? Alright, so then I also want to enter the results. So over here are the results. And I'm going to move over to list 2. 8.9, enter. 8.24, enter. 8.35, enter. 8.54, enter. 8.54, 8.72, 8.67, 8.68, 8.50, 8.55, 8.59, 8.34, 8.31. Okay, notice that at the bottom here, every x value lines up with a y value. There should be no extras at the bottom here. Okay, so all these line up. You should scan through and make sure that you have all the information entered correctly. Okay, because if you do not have the information entered correctly, then you are not going to get the correct equation for your line of best fit. Okay, all right, so once we've done that, what you want to do is you want to go ahead and go back to Stat, and you're going to go over to Calc, and they told us that it's a line of best fit, so you're going to scroll down to number 4, which is line regression. I'm going to press enter. Okay, x values were in list 1, y values were in list 2. Don't worry about that one. Store regression. So we're going to store the regression to the y equals. And we want to do that because eventually we're going to go ahead and plot that line. So in order to store the value into y equals, you are going to alpha trace. You see the first one is y equals, so press enter and then calculate. Alright, so here's our information. So our line of best fit, notice that we have y equals ax plus b. A is going to be your slope, and then they give you the information here. So y, 10, y equals negative 0.0033x plus 8.617, and the calculator y equals negative 0.0033x, so that's this piece right here, and then plus 8.6171, which is my b value. So the next question says, what does the slope of the line tell you about the average rate of change in the length of the winning long jump? Okay, so I think that if we look at the graph of this, this will help us. So what we're going to do is we're going to go to y equals, okay, and notice because we put in there that we wanted the results stored in y equals, we have our equation of the line here in y equals as well. It's already there. Okay, but we want to turn our plot on, so if you scroll up one to see where it says plot 1, and then you press enter. Okay, notice now that that's highlighted, which means plot 1 is now on. Alright, and then you're going to go to zoom, and then down to number 9, which is zoom stat, so it'll give us a picture of those points. Okay, so I kind of sketched out a little picture here for you to see. So the results is on your y-axis and the years, okay, or on your x-axis. So when I'm here at lower years, so like 1968, notice that my results were higher because 8.9 was one of the results here. But that as the years go by, okay, so wait out here in 2012, they weren't jumping as far. Okay, so that's what this line is showing you, that they're not jumping as far. So what does it tell you? That it has an inverse relationship, and that as the years pass, the results get smaller. You could also write that this is an inverse relationship. Okay, the next one says, use the line of best fit to predict the winning jump for the 2016 Olympics in Rio de Janeiro. So what we're going to do is we need to look to see where 2016 is. You could do this a number of ways. So 2016, first of all, we got to figure out what our x value is in 2016. Okay, so our x value in 2016 is going to be x equals 56. So my suggestion would be to go to second trace. The first one is value, so this allows you to enter X value, so I'm going to press enter. And then ask for the X value. Well, we found out that our X value was 56, so we're going to enter 56. So our Y value is going to be 8.4322, and this is in meters. All right, the next one says use the line of best fit to approximate in which year the jump should have been 8.47. So this one's a little different because I'm saying Y equals 8.47. Okay, so when you have a Y value, you can't use that calc button, so you're going to go into Y equals. So Y equals 8.47. Then we're going to go back to the graph. Basically, you're looking for where Y is 8.47. What's the X value? Well, the X value is going to be where that intersection is. So now, once you've typed that into your Y equals, you can go to second trace, intersection. Okay, notice that the cursor is on this line. I'm going to press enter. It jumps down to this line, press enter again. Then I want you to guess, press enter one more time, and then it says where Y is 8.47, X equals 44.5. But remember that X equals 44.5. We're looking at a particular year. So 44.5 would have been about 2004. 2004 to 2005, somewhere in there. Okay. Remember, again, all this information is on the sheet here that they should have been given to you. Okay, creating your scatter plot, turning your diagnostic on, line of best fit, and then we have what if given X value, predict Y, given a Y value, predict X. All this information is on the sheet. Okay, next one is, does the scatter plot represent positive, negative, or no correlation? Okay, so if we go out back to our linear regression, this menu right here, so we know because that slope is negative, that means that there is negative correlation. And it says, what is the correlation coefficient for this data? So that's back at this menu right here. And it is negative 0.2617. Negative 0.2617. And again, you have to have your diagnostic on to get this. Don't worry about the R squared. I'm just only looking at the R equals. If this is not on your screen anymore, you have to go back to Stat, Calc, down to Linear Regression, Calculate. That's where I get that R equals. Okay, and then is this, how strong is this? Remember on the previous page we talked about how strong the correlation is. You have a range from -1, the middle 0 is no correlation, and then the +1. Okay, so this is very close to 0, which means this is not a strong correlation. So I would say weak correlation. And you can also look at the graph and understand that. If you looked at this graph, look how far away all the points are from our line of best fit. So that's a weak correlation. Okay, explain the circumstances that would exist for an Olympic sport to have a positive correlation over time. Give an example. Okay, we kind of actually already talked about this a little bit. So remember this graph I sketched out right here, saying that in 1968 they were jumping much further than in 2012. Okay, so positive correlation, so it's going to look like this. So remember, this is time, so this is the number of years, and this is whatever result. You can pick whatever sport you want. And this time it's going to have a positive correlation. Okay, so think of an Olympic sport. Okay, let's say high jump is our Olympic sport. So let's say in 1920 they were only jumping, 1.5 meters. And then in 1950 they were jumping 2 meters. And then let's say in 2010 they were jumping 2.5 meters. So this would be a positive correlation. So the more time that goes on, the higher the results are for the high jump. That would be a positive correlation. You could choose another sport, but this was the example that I thought of. All right, let's go on. So it says, what are the special cases for solving absolute value inequalities and equations? Okay, again, it says, see your notes on day 4. I'll go ahead and summarize what our special cases are. Okay, our special qualities for inequalities are when I have an absolute value of some number or expression is greater than or equal to a negative number. Or absolute value greater than or equal to a negative number. So an absolute value is always going to be greater than a negative number, so this would be all real numbers. Okay. All right, the other one for inequalities is I have the absolute value of some number or expression. The key here, though, is that it has to be isolated. The absolute value has to be isolated first. Okay, so absolute value less than a negative number, or less than or equal to a negative number, is going to be no solution. Okay, that's for our inequalities, and then our special cases for our equalities. Absolute value is equal to a negative number, which we know that that's not possible, so equal to a negative number means no solution. And then when you have an absolute value or expression equal to 0, you only have one solution. Okay, and we'll look at examples of those in just a second. So you want to watch out for those examples. All right, let's go to the last page. All right, so the first step for solving these, you need to isolate the absolute value. So that's the first step. First step is to isolate the absolute value. Isolate the absolute value. So if I'm looking at this problem right here, I need to add 4 to both sides. And I have negative 2 absolute value of x plus 5 equals negative 4 plus 4 is going to be negative 6. And I'm going to divide by negative 2. So then I have the absolute value of x plus 5 equals positive 3. Okay, so the absolute value of x plus 5 is positive 3. So the second thing is, once you've isolated, check for special cases. Okay, check for special cases. This is not a special case, so then the next step is to set up your 2 equations. Remember, because there's 2 answers to these. Okay, one to the positive and then one to the negative. So I should have a positive and a negative. Sorry about that, you couldn't see that. Okay, so I have x, so I'm going to write this over here. I have x plus 5 equals 3, and then x plus 5 equals negative 3. And now you're just going to solve. So then the last step would be to solve. Okay, so I have minus 5, so x equals negative 2, minus 5, so x equals negative 8. So those are our two solutions. All right, let's look at the next one. So I have the absolute value of x plus 4, then on the outside minus 9 equals negative 11. So I'm going to plus 9. So the absolute value of x plus 4 equals negative 2. So the absolute value cannot equal a number, so you can stop right there. You do not need to do anything else. We're checking for our special cases, so this is no solution. Absolute value cannot equal a negative number. All right, next one. The absolute value of x plus 4 minus 7 equals 15. So isolate our absolute value. Absolute value of x plus 4 equals 22. Check for special cases. It's not special. So we're going to set up our two equations. X plus 4 equals 22. X plus 4 equals negative 22. Now we're going to solve. So x equals 18 minus 4, x equals negative 26. So x equals 18 and x equals negative 26. Okay, let's go on to the last one, 31. Okay, number 31 I wrote on the back because I needed some more room. So there's nothing that needs to be isolated. This is not a special case. So we're going to set up our two equations. Okay, then we're going to solve. And then our answer should be x equals negative 5 over 3, x equals 3. It's fine that it's a fraction. Don't feel like you've done something wrong just because it's a fraction. All right, let's go on to the next group. Okay, for these, solve each of the following absolute value inequalities, then graph your answer on the number line. Okay, the steps for these are very similar, except when you set up your two inequalities, when you do the negative, you have to change the direction of the inequality. So that's our extra step for those. Okay, so let's take a look at the first one. We still need to isolate our absolute value. So we're going to divide by negative 2, divide by negative 2. Remember, the rule is when you divide by negative 2 for inequality, then you have to change the direction of the sign. I'm going to go and write that over here. I've got x plus 4, absolute value, and I'm going to change this to greater than, because I divided by negative 2, is greater than 4. All right, check for special cases. Absolute value is greater than a positive number. That seems reasonable. So now we're going to set up our two inequalities. We have x plus 4 is greater than 4, and then x plus 4, and here's the extra step, is less than negative 4. So there's an extra step there. You've got to switch the sign when you set it up equal to that negative. Now we're just going to solve. Minus 4, so I have x is greater than 0, minus 4, x is less than negative 8. Okay, and then we need to graph that on our number line. So because I have 0 and negative 8, I'm going to put my 0 over here. So 1, 2, 3, 4, 5, 6, 7. Put negative 8 down here. Okay. All right, so then I have x is greater than 0. So you need to say to yourself, is that a closed or an open circle? So x is greater than 0, so that's an open circle. Okay. And x is greater than is going to be shading this way, greater than, so more than 0. and then x is less than -8, so less than gets an open circle, and less than -8 is going to be shading to the left. Okay, so that's what our graph would look like for that one. All right, let's take a look at the next one. Okay, I wrote this on the back just to give me a little more room. So -2, -2. So then I have -4 absolute value of 2x minus 1 is greater than or equal to 8. Then I've got to divide by -4. Remember, we're isolating first. Absolute value of 2x minus 1. Okay, we divided by a negative number, so we have to change the direction of our inequality. 8 divided by -4 is -2. Check for special cases. The absolute value of 2x minus 1 is less than -2. So the question is, can the absolute value be less than a negative number? It cannot. So that means that this is no solution. Okay, so you wouldn't put anything on the number line. That one would be no solution. Okay, for the next one, 34, so we're going to isolate by dividing by 3 on both sides. So that's going to give me the absolute value of x minus 2 is greater than -3. Well, the absolute value greater than a negative number, so that's going to be all real numbers. Or you can always use your fancy R. So all real numbers, so if this is 0, I'm going to shade in both directions all the way over here to -infinity to +infinity, because the absolute value is always greater than a negative number. Okay, let's take a look at the last one. So we're going to subtract 5. 6, absolute value of 4x minus 3 is less . Okay, so that's less than 12 divided by 6. So the absolute value, I'll write it over here, absolute value of 4x minus 3 is less than or equal to 2. Okay, check for special cases. In this case, there's no special case in this one. So I've got my two setups. I've got 4x minus 3 is less than or equal to 2, and then 4x minus 3 is greater than or equal to -2. Okay, and then you're going to solve. Plus 3, 4x is less than or equal to 5 divided by 4 divided by 4. So for this one, x is less than or equal to 5 over 4. Okay, and then we have our other setup over here, plus 3, plus 3. So -2 plus 3 is going to be 1. So 4x is greater than or equal to 1 divided by 4. So x is greater than or equal to 1 over 4. Okay, so then we have our two answers here. We need to put those on the number line. So if you're not comfortable with fractions, you can change them into decimals to give you a better idea of where it goes on the number line. Just do 5 divided by 4, which is 1.25, and 1 divided by 4, which is 0.25. Okay, so we have 0, and then we have, put our 1 here. So we have 0.25, which is going to be about right here, and it says greater than or equal to. So greater than or equal to means that it's going to be a filled in or solid dot. So that's our 1/4. And then we said 1.25, which will be about right here. So here's our 5 over 4. And again, it's less than or equal to. Now we're going to shade in. So x is greater than 1/4, greater than. So we're going to shade this way. And x is less than 5 over 4, so we're going to shape this way. So this is what our graph will look like on the number line. Okay. All right, let's look at the last one. So it says give the solution to each of the following. Give the solution. Well, when you think solution, when you read that solution, you should be thinking x-intercept. Okay? So the first thing I'm going to do is I'm going to circle where I see the x-intercepts in any of them. X-intercept. This one does not have an x-intercept, so this is no solution. Do not make something up. If it's not there, it's not there. Does it ever go through the x-axis? No solution. Okay, notice for absolute value, we have two answers. We have an answer here, and we have an answer here. Okay, for this one, we have an answer here. Notice here, there is nowhere it goes through the x-axis, so this is no solution. Okay, we've got an answer here and here. And then this one, we've got an answer here, and I can't see the other one, but you need to be able to predict that other one. So I know that somewhere out here it's going to also go through the x-axis. So let's look at the ones that do not have no solution, so we can say about where it's going through the x-axis. So this one, I would say, and you're going to write it as x equals, so it's right before 1, so let's say 0.8. We said no solution, no solution, no solution. Over here, okay, we have right in the middle, so I would say x equals 0.5, and then right after 4, actually it's about right after 3, so x equals 3.5. Because there's a 4, so 1, 2, 3, so I'd say 3.5. Right, this one here, we've got x equals -1, no solution, x equals -5, and x equals -1. Alright, and then our last one. Okay, and then for the last one, you can see clearly that it goes through x equals 1. The way to figure out this other one, if I look, remember that this has to be symmetrical. So if I'm going right to the vertex, I'm going 1, 2, 3 to the vertex. Well, then the other x-intercept has to be 3 on the other side. So 1, 2, 3, which would put me at x equals 7. Okay, because remember it has to be the same on both sides. Right, and that is it for the Unit 2 review.